The old man Bill. The old man Bill. The old man Bill. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone, my name is Nathan, otherwise known as Old Man Builds, and man, we are going to be talking the moon landing today. Do you think it's real? What's going on, everyone? Going into the woo a little bit, huh? Gonna have some fun. All right, guys. Yeah. So basically, we were watching a little bit of a podcast today, and they were talking about the moon landing, if it was real, and how much fuel it would actually take to get to the moon. And they figured it was somewhere in the neighborhood of like 8 to 10 more Saturn rockets filled with fuel in order to get to the moon and back. The fuel needed. And then they said that they lost the technology to get to the Van Allen belt. So strange occurrences also happen when it's go to the moon. It's kind of crazy, man. They were talking about astronauts passing away, taken out, you know what I mean? Things like that. It's a wild story. So what's going on, everyone? We'll say hello. So I always thought that they went to the moon. Let's just say it up front. So, you know what I mean? Growing up, you get all the stories that they went there and everything. And then it's not till later in life you start to see that there might be something different going on, that they may not have gotten there, that they're set up, that they're just doing the stuff on a Hollywood set. And then you start to understand the whole science behind it. And they talk about the shatters of meteorites hitting the moon, and that the lander itself wasn't that thick. It's like 2 pieces of aluminum foil. I mean, how do you even get in that in space? That doesn't even sound right at all. So then there's other things that say it could have been a 1/4 inch thick. Well, a 1/4 inch thick is not going to protect you from any radiation, not of anything. It goes right through metal, unless it's lead. So you would have to make massive amounts of lead. And they were talking today about maybe 3 feet of water would protect you from the radiation. It seems odd. It really seems odd that they're talking about all this stuff, but they said that we've already landed there. So where I originally thought we had landed there and we did all right, now the science doesn't make a whole lot of sense when it's broken down. I just never thought about it. I thought they had it, you know what I mean? But yeah, I guess not, man. This is weird. Okay. Yeah, now you're not sure. Yeah, I'm not sure either, man. Van Allen belt for radiation? Absolutely. There's a ton of radiation out there. It holds it in, by the way. So it's not like you can escape it. Let's see. Yeah, look, pastrami on rye, yeah. Can't have that these days. Yeah, the aliens are waiting. Well, they first got to get to that Van Allen belt, and you're not going to do it without another field. Oh, let's see. Oh, the television interview. Yeah, that was bad, wasn't it? They sat up there and looks like somebody just killed their dog, huh? That's what it looked like. So yeah, that was pretty sad. That you think if you get to the moon, you'd be all excited, man. Now you might be lethargic when you get back and stuff, but there's still got to be some life in you to jump up and down that you did something that no one else has ever done. But I guess they didn't. So I guess see why they're disappointed. They also lost all the original film. Yeah. Well, I don't think they lost it. I think if they're covering it up, they got rid of it. So what does that mean for us? We always want to build anti-gravity. So, I mean, does that mean we got a lot more to go? That we haven't even conquered space in any significant way? So, I mean, does that mean we have to work that much harder to get to the Van Allen belt now? If we want to go to the fly into the moon or Mars? I mean, maybe that's really what it is. Yeah. Yeah, getting past all of it. Yeah. Tell me how it feels to be the first man on the moon. Oh, all right. All right, guys, here we go.
Very, very fine grained as you get close to it. It's almost like a powder. Ground mass is very fine. I'm going to step off the limb now.
That's one small step for man, one giant leap for old man Bill. Houston, we have a problem. Houston, we have a problem. Old man Bill is on the moon. Oh, man, I'm sorry I had to do it, man. Oh. Yeah, well, I'm not disagreeing, man. I mean, it looks pretty difficult for them to do it, man. This looks much more realistic. Oh, man, that's so awesome. Yeah, to be honest with you, man, it seems crazy because we all thought, you know what I mean, shoot it up there. They start talking about the force and whip yourself around Earth's gravity, get to the moon, whip yourself around the moon, you know, the gravity of that to fly you back. And then they start talking about the propellant needed, and it's like, oh, okay. So is it continuously needed? That's kind of a question too. You know, you have an ion engine up there in some of these crafts, so does it really need that much fuel to go there? Or is it like they say, hit it with some gas, man, then lay off it and let it cruise? So, I mean, we're going to have to figure that part out as well. So, I don't know, man. Remember watching Sputnik? Yeah. Well, they definitely sent a satellite up there. Well, at least they hope. You know, they did now. We know that the Chinese program has a lander on there and that they're getting information from it. So I guess the question is, does that lander have any kind of those meteorites hitting it? I mean, that's a question right there. If it doesn't, then maybe that's probably, you know, not correct. So we would have to see if that's there. What did it take to them to get there? So if they got a lander there, then, hey, what did it take? Because we're going to have to find out. They probably have sensors and probes on it to see what kind of radiation it was to go through the Van Allen belt. Where did they go through the Van Allen belt at? The top, bottom, through the middle? What did they actually do to get a lander there? Is the lander actually there? That's a good question. Did they actually have a lander there? Or is it another psyop? So it's an interesting question. Oh, yeah, not supposed to be cussing like that. Oh, sorry. Yeah, big ice hole. I heard it's a heat hole on sometimes of it. When you get to the wrong spot of it, it's super hot. When you get to the other side of it, it's super cool. So, yeah, there's some hot and cold issues there, and batteries don't work well on either one of them. So let's just say that. Vertically landing a rocket, they talked about Elon Musk took them 6 tries, I think, to vertically land a rocket. But every time that they landed on the moon, they were able to do it. Could have had something to do with gravity. But, either way. I just questioned some of the stuff that how cheaply made the lander was. And that really got me. That's just, there's no way, man. There's no way. I wouldn't go out in that. That's ridiculous. I mean, I guess they do spacewalk, so they think, oh, well, you don't need much to land on the moon. There's not a lot of gravity there. Wouldn't really matter. Yeah, I guess, man. But tinfoil? That thickness tinfoil. Man, I wouldn't cover my head with that little bit of tinfoil. It'd be like 5 layers of that stuff if I was trying to protect something. There wouldn't be no 2 layers. That's ridiculous. I don't care if it is gold foil. It's still ridiculous. And then I thought gold was a great conductor. So what are we doing conducting electricity instead of blocking out the rays of the, radiation out there? I mean, what's up with that? How does that work? So I don't know, man. They they got Elon Musk to go out to space, so he's still, within the Van Allen belt. So let's see if he can cross it. I mean, give that guy the money and shoot them rockets out there, and let's see what they say. And not the rockets they keep painting on the side of his vehicles. I'm talking about the real ones. So, am I sure they landed a rocket with Musk? Yeah, I'm positive of it. I saw that. Yeah, he's definitely doing that. Bird of shadows, the rockets feel fire. No, he landed those. I'm sorry. He definitely landed those back on Earth or in the water, ships, whatever he got them on. The red rocket, don't know anything about the red rocket. You ever seen a saucer? No, I haven't. If I did, I'd make them pick me up and fly me around the world, man. But I haven't seen one. 100 feet, man, that's a big saucer. So, yeah, moon landing, man. I don't know. It calls into question, and they started talking about as well when I was watching this podcast. They started talking about all the mysterious things that there was CIA agents over there talking to the people, the crew, telling them when and when they can't talk, so they make sure they obey the delay in the timing that the signal had to come back for when they talk. That's a bad sign. Anytime the CIA is involved, they said that they had CIA all over the rocket itself when it before it took off. And then the original person had an accident before he was supposed to go up for the moon landing, and they had to get an alternate person in the crew because he wouldn't go along with it. Is that right? Is that wrong? I don't know. But it seems bad. Yeah, there was a training accident or something. Dude, anytime you got a hangar full of dirt and you're putting a lander in there for any reason, that's a bad sign. That is a horrible sign. It's like going out to Arizona with the rover. You know what I mean? Let's get a Martian landscape that looks all red. Let's drive a rover right around the desert of Arizona, and let's just say it is what it's not. That would be horrible. I mean, literally, I don't care if it's a test or not. That's horrifyingly bad. You should never do that. I mean, it ruins your credibility. So, yeah, definitely see them land. Okay, 2 triangle-sized UFOs and yeah. Yeah, you definitely got some UFO experience there, man. Everything's a scam. Well, yeah. Apparently it's showing that it is, huh? We get UAP, that seems to be a scam. UFOs, are they real? I want to believe that they are. I'd love to see one in person. Just like His Highness did. That would be really cool, man. I'll be honest with you. Are they made by us? That's the biggest question there. Or is it something else? Because this 6th generation fighter they came out with is pretty insane in the stuff that it's available to do. And even, the P-2 bomber with the stealth capabilities is kind of crazy. So, yeah. What's up, Mike? NASA definitely lost its credibility. Yeah. As soon as you say you can go through the Van Allen belt and you can't now, and that you can't figure out how it was done, or that you destroyed any equipment that should have been in a museum, yeah, we got some problems here. There's some pretty big holes in it. Danny Jones, yeah, big shout out right there. He did a podcast. That's the one I was watching. Really, really good. I like his show, man. He does great work. Oh, yeah. Yes. Man-made. Absolutely. You can call them UFOs. This is the first time I tried it. Really? I'll be honest with you, man. I think that they are man-made. I really do. I just think that they're man-made. I do not think that that they have aliens in them. I'd like there to be aliens. I like the green men, but I really don't believe that they're there. So, let's see. Interesting. Yeah, so it basically asks the question now, even if you create anti-gravity, is it worth anything if you can't get past that belt? You see, that's why everybody talking about fields around UFOs, things like that, because they know that there's no way that they go out to the rest of space without it. They couldn't. If you can't fly through the Van Allen belt, you cannot fly people through it with a UFO without a field shielding you from everything. That means the technology to get down there would be super high in efficiency and everything else just to understand this. So makes it that much harder for the rest of us. Yeah. Which makes you kind of call in question, did that, shuttle that was supposed to go up to space and everything, that Challenger flight, was that a bad op or what? I mean, was that all publicity and no go? It kind of calls into question everything when you look at it. Not that I want to feel that way or think that way or anything like that, but hey, if you're trying to cover something up, you can't have that kind of stuff out there. So let's see, an interview with William Lane talks about alien hoax. Cool. I'll check that out. Prince of the Sky. Yeah, it's extremely interesting when you get down to it, because you would think, hey, we landed on the moon, we got a flag up there, right? Well, how are we going to see it? Let's just take a telescope and you go see it. Well, we can't do it. We don't take images with that telescope, that big expensive one we have, the two of them. We don't take pictures of our galaxy, our solar system. We don't take pictures of. Why not? I mean, if they could see you picking your nose here on Earth, why can't they see, things on Mars? Every little bit of it, every single asteroid out there. Why would we not look at that first? I'm still baffled by that. If it was up to me, I'd have satellites all over every single planet in our solar system. And I'd be getting every bit of information that I possibly can. That makes you ask, is there a reason why we don't? Because we spent the money. We definitely spent the money to do it. I'm just going to tell you that. So why not have the information with it? Why do we not have satellites around the moon telling us what we're doing every day? Now, they may say that they have some, but we should be able to map this thing out, completely with no problem. Like GPS stuff, man. We should be able to take that little car that they drove around on the moon, if it's real, we should be able to put around on GPS, man, know exactly where we're going. So, God, man, which makes you wonder, they built such a crappy car to go on the moon. Was that like a joke? Was that like a bad joke to them? They started laughing as soon as they got into it? I mean, did they just kind of putt around the sound stage? That would suck. That would really suck. I mean, first thing I'd look at on the moon if I got there is a lunar shard. It's in ancient Egypt, right on the wall, right where you see the UFO picture. They have a picture of the lunar shard. That's one of the first things I'd be looking at to see if it's really there, to see if it's defying the gravity the way that it says it does. Those are kind of some of the things I would look for. Let's see if there's any historical things on the moon themselves. I don't know that I expect a base there or anything like that, but definitely the lunar shard, which is just a rock structure that has abnormal qualities. So, let's see. Whatever we built, they would only shoot it down. That's absolutely probably true. Let's say they were twins. I'm not sure what you're talking about there. Let's see. Thought it was going to crash in the front yard of the building. Man, definitely got a wild story going on there. Yeah, well, they talk about this stuff and some of the risks, and we can't go into the health here, but anytime there's UFOs showing up, people have problems. So it goes to how they built it. I mean, if you really think about it, it goes to how they built it and what fields they're using to do it. Pretty obvious they have some form of radiation in that field. And that could be X-rays. That could be, just radiation itself holding in the static. That could also be radiant. Let's see. Or, they could be microwaves from the high frequency of the static electricity in there. So it's kind of makes you wonder when you get to this stuff. But get back to the moon, man. It's kind of disappointing. I mean, look, if they didn't go to the moon, just tell us now. Just be done with it. Just whatever. It was what it was. We did it to beat somebody in a space race, and we lied our butts off, and that was it. And you know what? That's fine for me. I wouldn't care. Just tell us the truth and let's solve the problem the right way. That's all you got to do. That's it. Come up, be honest about it. Nobody has to get hurt. Nobody has to have any problems. Just tell us the truth. And if it's the truth that we can't do it, then that's it. And let's just, try to achieve it then. That's all I got to say about that. Sometimes, man, just coming and being honest about something and getting it to clear up and make sure that we do not have that stuff happen again is so much better than continuously telling us a lie. So, yeah, just come clean, man. If it's true that we got there, show the rest of the evidence. You know what I mean? If it's not, then tell us that. Because then it calls into question the rest of what you're doing. Did you really map Mars? Is there really a face on there? Are there really pyramids on there? Did we even get to Mars? I mean, think about that. If we didn't get to the moon, did we get to Mars? Did we actually take pictures? Is there a rover on Mars right now? Is there a couple of them? It really takes your credibility and puts it in the dumper, man. If you don't have proof for that. So I'll just say this, man, put up or shut up. Start showing us some more stuff, some more high quality images of this stuff. And of course it won't look like it, what we think it does up close, because nothing ever does. It's just the way it works. You can see a face on a mountain and it won't look the same when you zoom into it, but when you zoom out, it's pretty clear. That's okay too. Just be honest, put it all out there. So, okay. They didn't come clean about Roswell. They're not going to come clean about the moon. their whole thing is lies. So they couldn't even come clean about JFK. And we talked about that. So, yeah. I don't think they'll come clean either. I'll be perfectly honest with you. I wonder if they got there, and I don't think they'll come clean. We won't know in my lifetime because we don't have the technology to get there yet. I think we've already got the technology to get there. They would have to tell you the truth about what these UFOs really are in order to tell you that we can get to the moon. Think about that one. It might be directly tied together. Hey, we understood the problem, we fixed the problem, but we can't tell you the answer to the problem because it's top secret now. So that I have no doubt of. Well, let's see. Runaway military complex, yeah. They definitely are. There's no question about that. They get what they want, and they're able to build everything, and they made a lot of money off other countries being at war. That's not a lie. That's not a bad statement. It's just, that's a fact. So, good, bad, or indifferent, man, that's what they did. So, there's people supporting that in Congress, which I wish would just quit and get out. So, nothing I can do about it, though. I'm only one guy in one little state, and I make my vote like everybody else. Triangles. You know what? Crazier things is when you get into vortex geometry, triangles come up all the time. And they also talked about the B structure, that honeycomb look all over it. And because it's drawing in energy into it. So do I think that they did those things on the UFOs? Sure, I do. Absolutely. But getting back to this moon landing thing, that rocket, what a ride, man. Just to get to outer space, man, sitting on that big pile of fuel, getting blasted out there, that's not something I want. That's like a Acme rocket, man. Wile E. Coyote getting up on that sucker, man, and flying off. Not something I would really want to do. But, hey, all appreciation to those who've done it and, paved the way to get out there. It's interesting, though, how much radiation is there, because radiation in the Van Allen belt should be higher. However, that means that they're still suffering radiation when they're up there in space in the Russian space station. So the question's got to be asked, how much is it? And what did they have to do to shield that space station up there? I mean, that's going to give you a lot of answers, isn't it? You're going to have to figure out exactly, what's going on and what happens right there. Show Saul's plasma photo I shared. When I have a second. Yeah, I got the scope stuff. Now, that's not my scope. And I have to verify that scope, Joe, because that was wild. You know what? I'll go ahead and show it. We pull up what we're looking at here. Oh, man. Got to look for everything. You guys tell me what you think about this. Always interested. Let me cancel that. Let me pull it up as video file. Take a look at that. We always see a ring. I never see it like that. I don't know how this was done. I had somebody send me this, and yeah, that's pretty wild. Now, I don't know if that's a square wave. I know it's a square wave on top, but I mean, is that a square wave combined with a sine wave? Is it two square waves causing this rotation going on? I mean, I don't know. Let's play it again. It definitely wild. Looks like a vortex. It looks like it's supposed to look on your otoscope. Huh. Sean Scope doesn't show it this way, Joe. Sean Scope shows it, in the basic, up and down frequency pattern. I've never seen it swirl like this. You say you got one similar to that? I'd love to see it. And what is it from? I mean, that's kind of what I'd like to know, to be honest with you. Yeah, Joe's got me looking through everything to find a plasma. Let's see. Pulsing phase cancellation. Maybe. I can't see it that well, but those might be. It looks like two lines next to each other, and the top one's taller, which would be an H wave if you zoomed in, but I can't get a good image of it. Yeah, let's play it again. It's not the fact of what they are, it's how they're spinning. Because they look like a tornado, right? Looks like two vortexes spinning. That's what's interesting. Am I the only one that hasn't seen this before? It says it's like the Meg, huh? Well, the Meg definitely creates a vortex like that, that's for sure. But the show it on the scope is a little different. All right, let me see. Man, I can't. Hold on. Let me take a second here. Let me pull this up because I'm gonna have to zoom in on it. Always looking for something. Hate looking up stuff. Okay, here we go. Well, that isn't it. Well, that's the picture, Joe, that I got. All right, I'll see if you got another one. Yeah, it's the same picture. I don't know. I see the plasma. I know that there's frequency inside these tendrils right here. There's a bunch of little lines in here of frequency. I've seen that. The flow. Helicals. Yeah. Lightning across the field. Well, we could tell where the amps are and where they're not. That's for sure. The amps are all white and voltage just sprays out purple. Yeah, I'm more interested in that waveform, man, to be honest with you. Because I haven't seen that show up on my scope yet. Anyway, enough of that. All right, so keep talking about the moon, guys. A little bit of land and stuff right there. You get those vortexes showing, we'll be able to land on the moon. That's for sure. Let's see. Let's see what Joe said about it. Let's see. Those are the final frequency, regardless of Sean's scope, was showing with the discharge and display. The same as what is being displayed in the waveform. Yeah, like I said, here's the thing. You see it spinning, and we know that it's rotating like this. I mean, at this point, we know that energy travels that way. The thing that I'm trying to say, though, is seeing it on that scope swirling like that, I've never seen it. It's not the way that it shows it. It's not a 3D scope. You know what I mean? It's a 2D scope. So it always shows it just like this going across, right? It never shows it like that. Never. I'd be showing that every week if I could pull that off. Never shows it. Bases on the moon. You know, that'd be interesting. They say that the moon is hollow. Well, calls into question if they didn't land there, then how do they know it's hollow? You know what I mean? Just interesting. You know, it's if it rings like a bell, it means it has resonance in it, guys. That's basically what it means. You have a cavern with resonance in it. That's as simple as it gets. And what did they find down there? Oh, I don't know, just a bunch of crystal structure everywhere, all over the place, by the way. Pretty interesting. Should tell you what's really going on. Let's see. Yeah, I've never seen a scope show that. You can make it a skill soap, take your music. Yes, I know that. No, I haven't seen that. Yeah. Only semi-hollow. Well, yeah, that's kind of the point, isn't it, though? It says, right, but the scope is appearing dimensional due to the modulation patterns over time. Yeah. But that's the important part of it. Because, like I said, if it shows the ring in one way, this is showing the vortex of the ring. That's the part that's important. I want to know exactly. Now, he said on the message it was from a rodent coil that the scope was taken from. Now, that could change it entirely, right? Rodent coil is definitely putting out a vortex. So, how was it hooked up? And that's kind of some of the things I'm going to ask him. How was it hooked up? What does it look like? How do I reproduce it? How do I show it? It makes a big difference, guys, when we get into this stuff. You know what I mean? How's everything done? Is it truly two square waves meeting and then they create the vortex? Because that would be interesting. So it could be very well just be that the two square waves, because that's what rotates the magnet, right? In the vortex, it rotates a magnet. So that would make sense if the probe was there and they're creating a vortex. But I've never seen it on a scope like that. Yeah, rotating frequency with the frequent side of it. It might just be, the calm on the inside with a ton of energy. Yeah, and the rodent shape. The fit signal was from a rodent coil. It wasn't mine, or else I'd be telling you how it worked. Phase modulate. I didn't see the scope shots that look like that. If you did, I'm sorry. Send me the link to the video and I'll look at it. Let's see. Okay. I'm going to have to look that up. All right. So, sorry, we always kind of get off track a little bit, try to keep us going back to the same thing, man. So that's a lot of fuel that would be needed. I don't think it would need that. Not if space is what they say it is. You need fuel for stopping at each thing, and stop at the moon, you stop at the Earth, things like that. How fast do you want to go through the Van Allen belt? You want to build up speed before you get through it. The faster it goes through there, the less radiation you'll take in there. If it builds out that way, is there that much radiation in space beyond it? It kind of makes you wonder. They always tell you that space is empty. Well, it doesn't look like it. It looks like there's energy out there. You're just not calculating it properly. So, do we have magnetic fields that can hold in radiation? Yeah, I don't think that we do. I think we have radiation fields that can hold in radiation. It all depends on the density of it, but that's my thought on it. Magnetic fields to hold in a plasma, which is a static electricity. Yeah, I've seen that. But, not the other way around. It'd be different densities of radiation that'd be holding it in. That's why it's there. That would pretty much tell you that there's a scalar field out there and it's radiant in value that turns into radiation when it comes to space, which would make a lot of sense because it holds in static electricity, which we're in a positive pressure environment on the Earth, and we're at a very low static electricity. So when you do things that create friction here on the surface of the planet, it creates energy. As soon as you create energy, it's like static electricity. That's why resonance works here on Earth, because you're creating friction in the winding itself of a Tesla coil, so it creates energy that comes out of it. Pretty much how it works. You got to remember we're in a positive environment, and we always put things in a negative environment because we're thinking of space. Should we rethink that now? Well, is it still that negative inside that band before you get to the Van Allen belt? Well, or is it a bit positive? Is that why they say that there's a little bit of air in space, a little bit of water, a little bit of everything, just not in great quantities? So, definitely interesting. Oh, let me just tell you something right now. I have the rodent coil, and if that's all it is, the rodent coil, I'll have this thing and no problem. I have the circuit and everything, Jewel Thief, ready to go. Like I said, just see how they did it, what was used in it, and then we'll go from there. But yeah, definitely want to reproduce that. That's interesting. The tendrils is interesting in a different way because it shows the frequency in layers. It shows that you have frequency in a not in the scalar field, but a frequency in a magnetic field, I would say, like a potential field. So, and it builds in layers, and then it makes it swirling tendrils and stuff like that. So, I'm wondering if that rodent coil was pulling in some static electricity into it, which it should be from the environment of the room, and that's what the vortex is. I don't know that it's the square waves that we're seeing creating it. I think it's what's being created is the interesting part of it. That's why I want to know. Yeah, a rodent coil over that shoulder. Yeah, that thing's amazing, man. So there's another conspiracy. It's space liquid. Well, they tell you, man, but if they say there's transpermia, then there's got to be liquid out in space. That's just the way it works. So, what's going on, Lulu? Use a tube oscope. Okay. Well, yeah. Okay. Not a big deal, but again, this isn't a tube oscope right here. That's all digital. That's all digital. Now, I might expect something on an analog scope. Yes, I agree with you there. Not that. No, and Earth is flat. So many issues with the moon landing. Yeah, I don't believe the Earth is flat. I'm sorry. Physics doesn't work that way. No. Maybe if we're in an inner Earth, it would appear flat, but not the Earth that we're standing on. Not when you can fly in a plane, go around the world, and come back to the same point. It kind of ruins that whole fact of the Earth's flat. So we can already do that. That I'm 100% positive in. So do believe that there's issues with moon landing. Do not believe the Earth is flat. Let's see. Yeah. Okay. All right. Should have read that first. Yeah. Read that one first. Yeah. No. I did watch a video of a guy telling me the Earth is flat. It was interesting. Definitely interesting. But no, I don't agree with it. Yeah, read it first. Yeah. Flat Earth is round, flat Earth is not. Okay. Hey, look, I appreciate the fact that he said it. At least he believes in something. That's cool. Let's see. Yeah. Let's see. Fiber plug completely isolated. Interesting. Well, then that's what we'll look at. I know Sean built some big probes. Maybe I go over and watch that and see how he did it. Build me a big probe, put it in there. So we'll see what that frequency looks like, see if it swirls like that. Dynamic superfluid is his theory as well. Okay. Nobody really believes in that flat Earth, do they? The Earth is not round either. Well, it's not perfectly round, that's for sure. We know that. You need me to do a cap bank build video for what? Just for a rodent coil or something? I mean, cap banks are pretty straightforward. They're just a bunch of capacitors linked together. So what's just curious, what's the build for? But I can do it. I actually started working on the rodent coil and my geometry coil testing circuits. So yeah, I have that. I have one that I used for a long time on my geometry coil, which is circuit. I'll show that. For Tesla coil tuning, the cap. Oh, you want Ian's cap bank and how that's used? Oh, yeah. I have Ian's, and I can ask him if it's okay if I show it, because he did a great job putting the video together and building it. But if he says yes, then I'll definitely put that out there, because that thing is amazing. Brings you right to resonance. And by the way, for those of you who are looking at my Gravity Flyer video, tuning in that Tesla coil was not fun. I started with 2 of them, and as you can see, I wound the top one down to almost nothing, and there was a reason for that. The resonance frequency jumps. So you'll hit a radio frequency point on the top half of it. As you bring it down, you're going to hit the second part. Now, as you play with the cap bank, it'll jump between the two, right? I needed the top one because I needed the higher amount to be right on. So I had to bring the wire down and bring the wire down until I can get that frequency just right and get that resonance point in there, because it would go and you put it on the cap bank, it'd be there, it'd lock, And then all of a sudden, as soon as something happened, more energy picked up, boom, it was gone. It went to the lower frequency. So I would immediately drop probably about 50 kilohertz. And I can't have that if I'm looking for an exact frequency. So I had to peel back the wire on that Tesla coil. As bad as that is for when you built it, man, and all that time spent in it, you had to do it to get the precise frequency I'm looking for. It is still off by 1 kilohertz. And I got to get that reined in. And somehow I got to smooth that out because it's not smoothing out in the capacitor of that gravity flyer. So I'm going to have to figure that out, but I can reinforce it. So just to tell you what I did, I took my DC flyback and I connected it to my ZVS, which then I connected that to a frequency generator, which gives me the perfect frequency to go in there to match it. So now I can resonate them together. Everybody knows when you start resonating things together that they start creating more energy. So that's pretty much, it's a proven fact at this point. I've done it so much. So yeah, that's what I'm doing. I'm creating more energy by taking my resonance points and putting them together. So now that's going to also work with the Joule Thief because it's going to go ahead and it's going to pick up the energy from the piezo, which is going to be at the same frequency. The only problem is if the piezo is going off all the time, you have to shut that thing down with the energy you put into the Joule Thief circuit so that it overcomes that, so that when you push the button, it gives you the push that you need. Otherwise, man, it's just completely worthless. So, yeah, just interesting facts around that. Yeah. It's kind of hard to tune things in, man. Sometimes it takes a very long time to tune a Tesla coil just the right way. Once you have it, you can just measure the coil itself with the extra coil on top and just build a whole new one for the exact frequency and you're good to go. And you won't need a cap bank. You could just do it with a couple of capacitors and figure out exactly how much capacitance your number one coil has and then set it. So, astronaut train underwater for outer space water above the water. Yeah. Pretty interesting. I think they do that because it's the weightless environment more than anything else. Vibration needs to be stabilized to keep the distance and tolerance during the vibration phase. Easier said than done because you need the vibration. And, okay. When you rotate one disc and you rotate another disc and you have them in rotation, right? And you got magnets on the bottom, you're looking for the magnets to put eddy current to the top aluminum right there, right? Just like the short that I showed you, I want to affect the top plate. Now, I need them to run in tandem at different speeds. What does that mean? I need it to have a quarter wave, a third wave, or a half wave of the original frequency, which is the RPM of each disc. When those two things happen, both those discs get put in some form of resonance together, the entire craft shakes. The vibration is inevitable. It's going to happen. You're going to create it. It runs real smooth without that. As soon as you put that in there, the thing starts to vibrate and shake because you put it in resonance, which means you're resonating the energy in the craft itself. That's why it's shaking. It has nothing to do with a mechanical issue. There's nothing to do with bearings. You're hearing the piezo buzzer go off a bunch. You're not hearing bearings squeaking. Totally different process than what you really think's going on. Maybe I should do a better job of explaining it. Maybe I should run it so that it's very clear that it runs without having any kind of vibration in it, which it does. Even for the weight of the bottom magnets in it, it does. The reason you would want to use a link on magnets is because they are aluminum, because they would resonate as soon as the resonation happens in the rest of the aluminum on the whole thing. That's why it's all aluminum, so that it can resonate at the same frequency. That's why we're putting the Tesla coil at that frequency. That's why we're putting the high voltage at that frequency. Look, it's pretty much a done deal at that point. So let me pull this up. And I'm just going to show everybody right here in just a second.
Okay, I'm attempting to do a video here of an experiment for the Graviflyer.
That frequency right there is the frequency that the aluminum disc vibrates at.
I have the frequency generator set to 197.
Right there. That's what you got to set it to. Everything's got to be set. Can't get around that.
To a scalar canceling coil with aluminum bismuth core and the aluminum disc. I'm not even sure, I didn't measure the size. The point is it vibrates up aluminum. I have the tape measure there to verify how big the field is. So I run my palm in and out, feeling this vibration, and boom, there's the edge of it over there. And I don't have a free hand right now, or I would show you the tape measure will verify that at 197.44, which I had measured here. And basically, that's a verification of that frequency. It definitely vibrates up an aluminum disc. Okay.
All right, so we saw the frequency there, right? Sorry if I was talking over it. My headset turned off on me. So basically, he had a coil there, and it was in resonance. The actual coil, there were two coils put into one, tied together in links like this, and they formed a resonant coil. So it told you the frequency of the aluminum in resonance, not with just frequency attached, in resonance. Very important to understand it in that way, because now you know where to put it in resonance to affect the aluminum, not just a single frequency. Got to be two to be in resonance, right? Okay. Now, let me show another file to you. Find it real quick.
Today we're going to do a trick where we use a 9-volt battery to charge a capacitor to more than 1,000 volts. So how are we going to pull this off? Well, let's have a look at the equations. So our trick is to use a 9-volt battery to make a 1,000 volt capacitor. And the capacitance of a parallel plate capacitor depends on the area and the distance. So the formula is C equals epsilon A over D, where this is the area over the distance times a constant, which is the permittivity of the medium in between these plates, which in this case would be air. Capacitance is also equal to charge over the voltage difference between the plates. So if we equate these two equations with each other, we see that we can solve for the voltage as QD over epsilon A. Now, if we look at this formula carefully, we see that if you increase the distance between the plates, but you keep the same charge and the same area, then the voltage has to increase. So let's see if we can make this equation work in real life. So coming back over to our experimental setup here, we have our capacitor, and what I'm going to do is kind of make sure these things are close to each other. These two plates are close to each other, so I put a piece of paper in here, make sure they're not touching. And now what we're going to do is take our 9-volt battery and charge up our capacitor, and we see that we're at 9 volts here on our voltage display in that little box there. It doesn't show very well on the scale, but it's we see it's at 9 volts. So now I'm going to disconnect our power here. So the charge is now stored on this capacitor, and we're very quickly going to increase the distance between these plates, just like in the formula. So let's have a go at this. Okay, ready, it's set, go. And now we have more than 1,000 volts difference between these two capacitors. So it sounds dangerous, but there's not really a lot of electric charge here. So probably if I touch these two, goes back down to zero, basically. So anyway, what we've done is
Okay, guys. So let's just understand this, what he's talking about there. People get confused with the paper and stuff. Don't. You have a center plate, you have a top and bottom plate. You're pulling the top and bottom. When that piezo buzzer hits, that center plate goes like this. Okay? That's exactly what it's designed to do. You're compressing a capacitor. You're opening the next one up for a massive amount of charge. Then it comes back up and compresses it while it opens the other one back up. And then it compresses and opens until you get to a point where when this thing shoves that capacitor is now bulging like this. Okay? That's what you're doing here with that piezo. That's why that spacing has to be perfect in there, man. You literally, you're flux capaciting. You're changing the capacitance level in that capacitor. Remember, the discs are rotating with a static charge on them, so they're going to get a heavy charge. This guy's got 9 volts, man. 13,000, 10,000, that's where we start out with a DC flyback. I mean, we are in high voltage already. So when you start creating capacitor about that, you're literally creating a top one and a bottom one, and you're creating capacitance. The center will get saturated because of the Tesla coil. Because the Tesla coil and the static electricity will combine the energy, not cancel each other out. The Tesla coil literally builds on the plate. So if you see the plate like this, it literally builds out the inner field just like this. So it's forcing that energy back in that capacitor to each plate. So that's what's going on there. Those are the physics of it. That's as simple as it gets. The capacitance there, the voltage is there. What happens when you remove the amps from the voltage? You see, this is where people get tripped up. They think, man, I need a megahertz, right? Okay. What does a megahertz mean? And it means that you removed a lot of the amps and you took the high voltage and you shot it up. That's what it means. That's going to give you the frequency. The frequency dictates how much voltage and amperage you have in any circuit. I guarantee it. So what is it doing? It's dropping the amps, bringing up the frequency, and the voltage spikes. So will you have a megahertz? Yeah, and it shows up on the oscilloscope. As a matter of fact, it'll show up as 25 megahertz is what I've got. And it's in a consistent basis. Once that capacitor holds, it holds. And what you saw yesterday, if you watched the video, I'm going in and out of capacitance. I got a capacitor holding, then I have it leaking. I have it holding and then it leaking. You know, I'm dealing with a leaky capacitor because my high voltage wasn't set to the same frequency, so I can't continuously build the charge. So that right there, man, is it's kind of some of the secrets behind the sauce of what's going on here. I told you guys for all the videos you guys have watched, we're doing it in resonance. And I'm right. We're doing it in resonance. We're doing it in harmonics. It's got to be harmonically balanced. Your two discs are going to create a frequency whether you want them to or not. You have to create balance in between them in order for them to work in tandem with the eddy current. You cannot overpower any one part of this circuit or else it all fails. That's why things are left the same as the way the inventor made them. You don't want to change it because you're going to break something. Even though you get a more powerful static field, that's maybe not what you want. It's going to overpower everything. So there's a lot to it, man, that really stands out in how this is working. But yeah, it builds capacitance in it. I could tell you that as soon as I put the motors in tandem together where they have a a third, a quarter, a half wave in between them, which just means that the resonance frequency, which is the RPM times 60, gives you the resonance frequency. That right there has to match, okay, in some way. Like I said, in a quarter of the value of the top one, in a third of the value, in a half of the value, in 3/4 of the value. Just has to be like that. It's a fraction of the number. And then you could put it in one of the waves of the ring, which works on that scale. That's what you're doing with those two motors. They have to be in that. That's when the craft starts shaking. It creates a vibration in the craft that is not mechanical. It is energy-based vibration. That's what you're looking for, because Alexis, as soon as before it lifts off, starts to vibrate a whole lot, and then it turns and goes up. It's exactly the way it works. So you have to create the vibration in there and the energy enough to swing that bottom disc a little faster when it goes to lift off. So, yeah, there ain't no shielding going to help you from this. This is either you're going to do it or you're not. And it doesn't matter what's around it, because frequency, again, two ships in the night, man. If you don't hit it, you don't hit it. That I showed that with my coils. That's, again, one of the reasons I showed my coil videos, so you guys can see that frequency is important. It has to hit. Now, why does Aleki use cheap wires? Well, it's because when you get into a static electricity, your frequency is going to go all over everything. If you wanted everything at the same frequency, that's a quick way to do it, isn't it? Cheap wires, insulation's easy to get through, and frequency's not that hard to attenuate after that. It's a done deal. So that's why I went back on that project, because I had not seen the video of the aluminum. I've been trying to find that frequency forever. And I had spots right that it hit, and then it didn't. And thought I got it again, didn't. This time I got it. When I showed that video, I definitely saw it pick up, and it went right with the oscilloscope. As soon as it hit it, energy went up. As soon as it dropped it, it went down. Hit it, went up. Dropped it, went down. But now that I can take my DC flyback and put it at that frequency now, and I can hold it there without question, now we got something. You see, those wires don't touch the disc at all. I know everybody thinks they do now. They sit about a 1/4 inch off, no sharp edges. They got to go rounded like that. And that's because any sharp edge will create a spark, and that'll blow your capacitor. So that's junk. Can't have that. I've run this thing with all kinds of voltages and sparks, and I can tell you it's a bad thing. When it rotates, it picks up a static voltage. It's literally taking the air itself, okay? It's charging that air in that area. Just understand what that means. It's friction in the air. Anything in rotation has friction. Anything in movement has friction. When it contacts another object, it sparks. It's like going down the hallway in your socks and touching somebody. That's exactly what you're trying to do. You want static electricity all over that. Very high frequency, very high voltage, very low amperage in order to do it. That's going to start to create your field because it works like a plasmoid. You're literally pushing static electricity inside of a radiation field or radiant energy, and it holds it in. That's got to be achieved first. It's got to run for 10 minutes, and it's got to be able to fill up that bubble. Once it does, your capacitor has to set. Once your capacitor sets, you must take that jewel thief and ring it at the same frequency that it's ringing inside the entire craft of that aluminum. You see me working with my TV over here, and I'm going back and forth, because I'm looking for the thing to hit the highest value. Now, albeit I'm 80% deaf, guys. I can't hear it. Now, maybe you guys can. I can't. I tried to put on headphones to get it to work. It didn't work. I just have to look at the screen and tell you exactly when I hit the highest amount of frequency possible. And then I know I have saturation. And that's what I'm looking for. Once it's saturated, that means that I have a ton of energy inside of a core. Now on the what they call an ultrasound, which is a misnomer, it's a jewel thief. I have saturation of a jewel thief core, which means I have a massive burst of energy that'll put out a pulse wave onto the rest of it. For those of you who know what Tesla's earthquake machine is, it's a simple pulse. There's water hammer and steam hammer at the bottom, which create pulses, right? It goes like this to attenuate the frequency up and down, right? Two frequencies and oscillation is exactly what the top does. The bottom's water hammer or steam hammer. That gives you your pulse wave. That amplifies the amount. It becomes a resonant frequency instead of a resonance frequency. Big difference in understanding resonant frequency is the absolute maximum value of energy that you can get out of it. It's exactly what we're looking for. That's how you're going to push that capacitor. So it's a ton of understanding, but it comes down to this simple point. Between your motors, your Tesla coil, and your jewel thief, you have to put all the frequencies in the correct order. They all got to match. They do. It's just that way. As soon as that buzzer goes off in any way that you didn't want it to go off, you're killing your capacitor. And you hear me say it in the video, I'm killing my capacitor right now by this thing going off. I'm wasting energy. It's literally making it go off before it's ready. It won't let you build up energy on the plates. So the idea is simple. Guys, if you're looking to understand this, you say, well, you're building a hydrogen atom. Well, yeah, it's like that. You say, well, you're building a plasmoid. Yeah, I am. That's the whole point. Our whole planet is basically a plasmoid. I mean, think about it. You're taking radiation energy, you're holding in static electricity, you're literally creating a plasmoid. And you have to do that. If you ever sat and just watched bubbles, and it sounds stupid, I know, watch how they act in the environment. You'll see all of the light spread out on them. You'll see that they do not behave in nature like they're supposed to. And you could say, oh, well, they're super light. Well, people say that about bugs, but bugs don't behave in nature like they're supposed to either. It's literally coming down to creating a vacuum cavity when you're creating the plasmoid. That's what you're doing. You are taking everything out. You are pulling everything out of that cavity, and you are literally forming a negative inside the cavity, which pulls all the air out. That's what you're doing. You're building a plasmoid to do it. And it's going to give you like a vacuum chamber on the inside. That's how this process works. It pulls it out. You have the energy there, one holding in the other. And it has to do with density of energy. So when I tell you it's a radiation field or a radiant energy, that literally holds in static electricity. It's exactly the same process as a plasmoid. That's exactly what's going on inside of it. You're holding in that energy. Why? Really thin, hardly any magnetism to it is static electricity. Radiant energy is the opposite side of that field. So if I told you magnetism and static electricity are on the same field, right? I'm going to tell you also radiation and radiant energy are on the same field. Now they're opposites. So when they hit each other, they force together. When they force together, they cause friction and they cause plasma. So when you hear Sal Paez talk about it's causing plasma in around it, well, he's absolutely right. Just like the bubble. You want to see a bubble in the air, that clear plasma, just like we have around the Earth. That's exactly what this field is creating. That exact form is exactly what it's creating. That's what you're looking for. You'll find the points where the energies come together because you can put a light into it, it'll light up brighter. You can put your AM radio next to it, and you can hear the static in it. Even though I'm deaf, I can still hear the static in it, guys. I know where the fields are combining. I know where they're hitting, and I know when they're forcing themselves against each other, creating that plasma. So It's not hard. It'll create light in that form, which makes a light just like your bubble would. It's spreading that light all over it. All the colors of the rainbow are right in that light, and it's just going to start refracting it. So that's what's going on in this whole process. So people tell me all the time, "Oh, it's a fake, it's a joke, it doesn't work." I go, "Well, why are all the physics working? This drives me nuts. Why in the world are all the physics working then? Why? You think somebody came that far and failed? I mean, seriously. To find out this information, you really got to do a deep dive into physics and find it. You got to know how a plasmoid works. You got to know how capacitors work. You need to know how to charge a capacitor. You know how to put a third plate in a capacitor. You know that you have to have a resonant frequency in order to make this thing pulse the way it needs to in that way. How do you know that? You need to know that magnets themselves are a grounding point. Did anybody know that? That you have to put grounding in it in order to pull the energy. You have a Tesla coil that runs through the radiant side of the inside of it, which then only works when you put heat to the other side of it and it pulls that energy in. So what happens when you have two rotating discs that are in static electricity, which you're going to have heat on them? And he shows this in a red light test that shows you the field perfectly. And it's pulling that energy towards it by doing that. How does he know that you can put this thing on the ground and it'll pull in the energy so much faster? But if you have it in the air, it absolutely will not pull that energy in. How does this man know that and fail? I don't understand. There's too much. Every bit of anti-gravity research is based on this. This is the exact way they're building it. Everything that I've ever seen is doing it. It's creating a temperature differential between the outside and inside. It has it. The fact that he's lifting 3 pounds of weight is incredible. That's what really bothers me when we look at this stuff. Here it is, teaching you how to do it, the fundamentals of everything, the cold energy side, the hot energy side, the frequency jump, everything, man, how to create energy on the outside, how to form a plasmoid. Look, I can take a geometry coil and form plasmoid in seconds, man. They'll be really small and they can go through just about anything and like eat away at any kind of thing that you have on your coil. It's easy. It's basically a field that's holding in another field that creates it so tensely packed that it creates a plasmoid. That's all that it is. Okay? You have to literally create radiant energy, okay, which is a scalar field which holds in the static because it's creating friction, so it's going to create static because we're in a positively pressured environment. That's simple. That's over unity, guys. It's literally has to create over unity and build this thing. It's all in one. There's no getting around it. I don't care which device or which coil I work on, man. It's going to do the same exact thing in the same exact way. The point of this, and the reason I'm sharing all this, is because I found the frequency of luminance, or I should say somebody else found it, and I'm very thankful that they did. So I can appreciate that, and the fact that we also were shown the capacitance and how it pulls apart. That means that when you push the piezo buzzer, your plate, it goes like this. It's flexing. That's why there's such cheap garbage plates, because he needs them to flex. Alexi showed a video, and it doesn't make sense until you understand why pulling a plate apart is so important. He literally had 2 plates of this stuff put together, right? And he goes like this, and he pulls them apart, and he's telling you that it has a bunch more energy in it. And you look at this thing, and you're going, I don't understand. I just don't get it. Well, he told you. He told you the exact process. Then he showed you another one with the little cardboard thing with the aluminum foil on it, right? And as soon as he put the wire down to it, again, he's taking the positive wire from a DC flyback. Hey, pay attention. He's telling you something. Touches it, nothing. Touches it again. Okay, now he doesn't even have to touch it, and it'll basically move the thing apart. What is he saying? As it goes down and it wobbles, okay, wobbles, it's creating capacitance as it does this. He told you the answer. He showed you the red light test. It told you where the field was. I mean, I literally drew it out on one of my videos, exactly where they were, where the heat points were, everything. It told you the heat points on the outside of the top and bottom disc. It is. And he told you how to draw out the frequency. He even showed you the Tesla coil, and then he put the wire in there, had a little stand on it, and had a light bulb, right? He touched the little stand, light bulb goes off. Let go of the stand, light bulb's on. It is the exact recreation I've done with my Tesla coils to show you cold energy. Exactly. To the T, exactly what he did. He showed it to you. We didn't understand the combination. Hopefully, if you watch my videos, you understand the combination. You are starting to put this whole thing together. When we start talking about the different combinations of frequency and things are a lock and how many do you need, think about it. Two discs with two different frequencies. You got a center plate, which is a different frequency. You got a high voltage, a different frequency, and you got a Tesla coil, which is a different frequency. Okay? Now you have the frequency of the bubble itself. We have 6 frequencies, which matches everything that you learn about a crystal. That's why I'm talking about it, man. That's why it's an understanding. That's why I go through the process of learning everything I possibly can. When you see a triangle structure, it always has a vortex in ancient writings everywhere, no matter when you see it. Why in the world would we put 3 legs on it? It is unstable and it sucks. That's because he wanted to pack in as much information as he possibly could to get you to understand this. Way ahead of us. Way, way ahead of us. He showed every test on his channel. He showed you everything you needed to know. He showed you exactly how it worked. It was up to us to decipher it. And if you can decipher it and put it in the correct thing and understand resonance properly, you have it. That's pretty much it. That's that whole craft. That's any anti-gravity craft you have. Is it 10 times easier to do it in a coil? Oh, you bet you know what? Is it so much harder to do it in this? Yeah, it is. In a coil, it'll probably take you, 10 minutes to build a circuit, if that. Build your coil, probably take you, 4 hours, 5 hours, depending on how complicated you want to make it, which layers you put into it. As long as you make sure that you understand the difference between hot and cold when you build circuits. I mean, like a negative circuit's not that hard. We use PNPs all the time. They're a negative circuit. They pull through the negative. It's not unheard of. They literally do it. You just have to use an NPN to do the same thing. You just have to understand how they work in the flow. I mean, this is the real deal. Why don't I use the coil to levitate? I have avoided in every way to show my rodent coil because Ben works on it. I have avoided showing my geometry coil in any way because Gerald works on it. I wanted them to have all their credit they deserve for working on those items. If I can help them and tell them something, I would. And I have. And they have done the same with me and helped me and told me things as well. I do not show it because it's not my project. It's theirs. I have my own. I could show it, but then I think I'm violating, what they do. And you see me build them. You see me put out a video every once in a while. I build a coil, and you can tell I know how to wind something, man. It's not really that difficult once you understand how to do it. And I try to make things look as perfect as I possibly can. The gravity flyer for me is an outlier. It was something I picked up, a project another person did, and this is exactly how they built it. So it's exactly the way I did it. So It doesn't look like my normal work because usually I'm a perfectionist, and I've wound my rodent coil twice, man. I round it once and I hated the way it looked, so I tore it all apart, cut it all out, and did it again. And that's just the way I work. So yeah, I'm trying to figure out this like everybody else. How can people get anti-gravity out of this stuff? What are the things that are going on? I guess you got to understand it in that way. You see, it's not to me about what can I change to amplify something. That's later. You get this thing to lift, man. Nobody cares what you made it out of. They don't give one rat. You know what? They're going to do it to amplify everything, but they don't care. They just want to know the underlying reason. It's as simple as understanding if I can't create 6 points of frequency, I can turn on a crystal. That's it. Do you understand the process? Once you understand it, all the technology is unlocked for you. I keep telling you guys what they are. I really do. I'm trying my hardest. I don't know that I can actually get across to you how important each part is. Hopefully, in some of this, you guys can understand this. So, yeah, are they using it for levitation? Rodent coil, no. The rodent coil is missing one half of it in order to create levitation. It pulls one vortex side in, not the other. You need both. It has counter rotation in it, but it's more of a over unity device when you put it in saturation. That's why I don't show the other part of that in there. When you take the rodent coils and the wires that are attached to it, once you have saturation in the core, then you can pull as many wires off as you want to, and it's still saturated. That's the point. That's why jewel thieves work that way. But you could take a whole different type of energy and put it in there and saturate it. And I've shown that. I don't think that the experiments that I do show you as well as I should on how much energy is actually there. For those of you who have followed and seen my motor that runs just for a few seconds in the capacitor, and I use bad diodes or slow-moving diodes, that creates amps. I've sat there and I put I've used the camera to see what the temperatures are. And the slow-moving diodes creates amps because it creates heat in there, which creates amperage. I try to tell people that, and they still don't believe me. But that's the process. You have to take a fast-switching diode in order to take the other side and put it into that same capacitor in order for it to flow energy fast enough to do anything. But that was only one wire off my coil. That was it. My rodent coil is saturated. I keep pulling every wire. I think there's 22 wires on there I can pull. One's a feeder inside, so that takes away that one. The other one goes to the outside, which is running that one thing that ran that little motor for a few seconds. I got a bunch more. I got 20 more. I can start pulling energy. I mean, it's not terribly difficult. The whole geometry coil, I couldn't show you that if I wanted to. Not mine. I know too much, and I don't violate that. And that's just the way it's going to be. I can't wait till the creator puts it out, but I won't do it. That's his and his alone. But it definitely pulls off things that you'd like it to pull off, that's for sure. And there's a whole nother understanding to it. It's on a whole nother level, which I wish I could talk about, but I can't. Anyway, that's why I don't mess with that and show you guys that. I do it. I do the test. I verify the work. You know what I mean? But I can't show that. Anyway, hopefully you guys you understand that. Sorry we got off subject, guys. I know a lot of you like to talk about that kind of stuff, but hopefully you get a better understanding of what's going on. The Benny Factor is the channel for for the rodent coil, and then Gerald's channel. Oh man, I couldn't tell you the name of that. Let me look it up. Okay, let me give you that. And I'll be honest with you, man. These are their projects. Go to their channels and watch them. Okay, this first one is Gerald's channel right here. And you're going to find the coil in there. Just trust me when I tell you that that thing does a whole lot more than you think it does. Even when you see the test, there's more to it. Okay, let me pull up the other one when we get there. That wasn't it. Sorry, just take me a second here. And here we go. Here's Ben's channel for the rodent coil right there. Hopefully those help you out. Yeah, there you go. I still don't know what that means. Whoop, Gen, lighten for truth. I don't know what the WP is for. Anyway, there you guys go. Those are those. So you guys can look them up. All the credit goes to them. I don't want to, jump in there. Just let them do their thing and show you what they want to show you. But they both are doing really good jobs on both. So definitely check them out. You want Ian's channel. Hold on. I get you that. Give me just a second. Matter of fact, I'll even let me find the video real quick. I'll go ahead. Here's Ian's channel for the Cat Bank. I'm going to show you some of his video on here. I'm going to share it with you.
It's here, Mark. Hello. I've been asked to show how to build these capacitor switching boards because they're particularly useful in getting resonance out of strange scenarios with testicles with rods down them attached to rodent coils. So they're very useful for changing capacitance within the actual coils themselves when they're resonating. Yeah. Where did that happen? Shit. Weird. All right. Well, that's just an example of what happens. Sometimes it throws a bit of a wobbly. That's about 2.3 kilovolts there, and it's given a frequency is about 124.6 kilocycles. It kind of likes that, 124, 125. But you can get it from so many different combinations of capacitive loading. It's very strange. And it'll disappear, and then you'll put some in and it'll come back, or then you'll take some out and it'll drop down, and then you take some more out and it goes shooting up. So it's very strange. Anyway, but it's useful to get it. I've got a discharge. This is just DC, low power, 12 volts going in. So got a bit of a discharge there, but I'm just running another experiment at the same time. So anyway, so that's basically what they're used for. I've got two here in parallel, and obviously in parallel with the ZVS board. And so because I just ran out on this and I had to put another one in to start be able to manipulate that as well. and that's what they're useful for. It's great. You've got 2,000 volt capacitors everywhere here, which is fine for parallel resonance. But if you're going serious with series resonance with this stuff, I've got 6 kilovolt versions of it. And rather than switches, you need little jumper cables to go in between the green terminal posts. But anyway, I'll show you how to basically make a board. Okay, so I've laid out, I ordered a bunch more capacitors. I should have checked the pin distance, because the MKP 10s are basically like these, those are 22 nanofarads, whereas these are 2.2. So you can see the footprint is much larger if you get FKP ones instead. But I basically got what they had in stock and thought I would just crack on and get it done anyway. So yeah, I've got a couple of 47s, 22s, 10s here, then smaller down to singles, and then 100 picofarads down at the bottom here, just to try and cover everything. So there's 336 nanofarads total on this board. Basically, this perf board is there's no metal on it at all, and that's better for high voltages. Also, credit where it's due, this is actually a Master Evo design. He came up with this maybe about 4 years ago, and I saw it and thought, well, that's brilliant, perfect for what I needed, and I've been using them ever since. So thank you, Master Evo. So basically, I've laid them out, and I've put just marked out where I'm going to put these switches. They've got a reasonably small footprint, so I'm going to just put them in like that, and the switches protrude enough so you can actually get to them. It's a bit crowded in this board. There's going to be like 40 switches on it, but I've only got 30, so I've ordered another 10 just to have enough to get it all done. But anyway, so 6mm drill bit seems to make the right hole size for these switches, and yeah, these are single throw double pole, something like that, STDP. And yeah, so I'll just crack on and I'll get the rest of the holes built, install all the switches, and then I'll take a look at how to wire it up at the back. Okay, thanks. All right, hello again. That's a rather dull task of putting all these switches in. I'm still waiting. I've got 10 switches missing here, but I've been cracking on anyway. Yeah, these stands are really useful for doing things like this. You can spin it over. The common traces, I've put those in. These are the, I mean, it's obviously, it's not polarized, but if you put all the feet that are together away from the switches into a common line, then that will then work, as this one works across here and across the back here. So it covers all the switches and the switches to go in. Then you can feed the end result of that back to the terminal posts, which will be in the other side. I'm not putting those in until I get these switches in, and then I'll put them on the outside. But
okay, real quick, I just want to, I'll put this back up and show you the rest. I have to say this about this so we understand what's going on here. Okay. All we have is an on and off switch. And then we have two parts coming out of your capacitor, right? So one side is going to be permanently connected all the way to the end. All that on one side with all the capacitors. One side of it is all going to the one side, which is the positive or negative side of it, okay? It's probably the negative side. Then the switches go between the switch and the cap. So the switch, which all the switches will be connected to the endpoint. Then as you turn each switch on, it turns the cap on. Hopefully that makes a lot of sense to you guys. One whole side of the rail goes negative. The other side has to be put between the switch and the cap. All the switches go into the positive side. That means as you turn each one on, it turns on that cap, and only that cap. Then you can turn them on and off in order to do it. So I'll play the rest of the video. I wanted to clarify that. Wasn't, you know what I mean, really clear to me when he was doing it that was what was going on. Hopefully that clears it up. I will see. Ian sent me a while back a diagram of this. I'll see if I can't pull it, and I'll just post it on the community page. So anyway, I'll put this back up for you guys.
But as you can see, I've just traced out the lines that made most sense for it. You've got all the single inputs here marked in red toward the switch that they're going to go to. And I want them all to switch on in the same direction. So some of these will come across to the actual activating pin here on the far side, whereas these are simpler because they're just going straight to the top because of where they are in orientation to the switch. But that's basically it. The common line that goes through the center of the switches is obviously for the other side of the capacitors, which is being switched. So they're being switched in and out in parallel. And this is the other side, which is just constantly on, going to the other input to the capacitor board. So again, we've got the one common to the pin that is parallel in all of the capacitors, and the other side of the capacitor is in parallel but with a switch on it to switch it in and out of the circuit itself. So all of these need a separate little wire going to each of the single switch inputs, which are then switchable on and off to add them and take them out of the circuit. Okay, so I'll update when that's finished as well. Thanks. Okay, so we've got all the little white wires are the other leg, the remaining leg of each capacitor being connected through to the switch. And so I've got all the wires connected for all the switches that I have, still obviously missing those 10, but this is getting it into a usable state. So it'll be quick and easy once I get the other switches in. So I'm just going to test it out and make sure everything is going as it should. Just connect the multimeter here to the two lines of the capacitor so that everything is switched off, all the switches in the down. I wanted them oriented one direction. Stop confusing myself. And okay, so that's on. That's a 47. It's showing 44.5. There's another one, which is 44.5 again. And I've been through all of these and everything works fine. All right, so, yep, cool. If anybody needs a schematic, I could give one, but it's really straightforward. And you see the way the switches are connected here. I oriented all the switches the same way up. So I think the writing was on, looking at it like this, the writing on the switch body was on the right-hand side. So that always meant that putting it up is going to switch it on and down is off. So that's how all the switches are configured. And to maintain that integrity, I just put a top on the two parts of each switch that are active, so it didn't tempt me to go straight from here to that leg, and then that would reverse the switching. So just something to look out for. Any other tips in this? Yeah, I tend to, when just putting these wires together, is just cut them all first of all, and then just using the tweezers here, I'll actually bend the wire around like that. Oops. Ow. And then just hook it on, guide it round where I want with the other end off, make another circle on that, and then just wind it around the leg of the capacitor, tighten them up at top and bottom, and then go on to the next one, and then just solder them all as a one thing. So there we go. Yeah, again, just to reiterate, one leg of every capacitor is on a common line, so they're all connected essentially in parallel, but the other leg is switched in and out of that parallel circuit. Simple as that. It's really straightforward. Time consuming, but very useful. All right. I hope that helps, and thanks for taking the time to watch. Thanks very much.
Okay, hopefully everybody can screenshot that. Pretty straightforward. It's a lot easier to look at this and see exactly how he did it. But that's it. He tells you all the stuff right there. There's your schematic. So I'll go ahead and I'll put this on the community page as well, guys, in case you need it, and you can screenshot it there if you need to as well. Real quick, I want to talk about this for a second. ZVS does have components in it that makes it hot. Yes. Putting it into a Tesla coil as an oscillating circuit is good because the center of your Tesla coil, if you put a small enough rod in there, is cold and it creates your radiant energy in the negative form. The outside of your Tesla coil is positive radiant energy. That's why you get a tan if you're too close to it. You have way too many amps. If you want to go ahead and loop a circuit, let me share. Let's see where it is. This circuit right here. And let me, before I play anything on this, I'll copy it. And there you go. Now, let's just look at this for a minute, okay? You have a coil set up. You have negative and positive. You see all the blue lines. We're pulling the negative through the circuit. That's what's happening. It saturates the coil first. Please understand this. This is only one side of it. You would need a separate MOSFET so you'd have two of them, and you're switching the coil in resonance. So one switching all the time, and as that one switches, it goes back and forth like this, so they resonate together in the coil before any heat is being produced at all. That is why it's a cold energy circuit. You pull towards the heat. That's why the neon bulb is there. You see it between C and E right there on your screen. And that in itself, sorry, hopefully that's a little easier. That little neon light creates enough heat in order to pull the cold energy through the circuit, which is your negative, which means that you're going to resonate that coil by using an NPN in a negative fashion. Okay? Right there is your over unity circuit that you're going to need, because that right there is cold energy to the coil before it hits anything that's hot in the whole system. Okay? Very important. Before it hits anything hot in the whole system, it's pulling the negative. Okay? That means that your coil is going to be cold. It will retain the energy because it's cold. That's what you want. That's the kind of circuit right there that you're going to need if you want to try to produce over unity for one reason. Okay? Its hysteresis is now removed. The heat will not escape the system, causing energy loss. It'll stay cold. Then what does that mean? Room temperature and a little bit below. That's it. We're not saying it can become a freezer in there. Same reason the MEG works. It's going to start cooling down in your room. The coil itself will start to cool down a bit. You'll get a temperature differential between the room and the coil itself, which will cause the heat to try to go to the cold and overcome it. It's going to try to overcome it, overpower it, is what it's going to try to do, right? In doing that, it creates the energy to pull into the center of it. If it's a rodent coil, it pulls to that swirl, okay? Just like it's designed to do, right to that vortex. Geometry coil does the same thing. Geometry coil is actually two coils in one, so they pull in resonance like this. They're creating vortexes on each side, which have a null zone in the center because they cross when this crosses this one. So you have a V right here, this point, and it crosses over the V at this point. That's when you get that null zone. That's where the big energy is. Okay, that's what you want. Anyway, That's a circuit right there. I left the thing right here. So if you want to go and watch that video and see that circuit right there, that's exactly what you need. If you want to try to loop it after that, be my guest. One thing I will tell you, it's a primary running circuit. What does that mean? It means the energy you pull out of it is going to be in the center of your coil, not from the running of it itself. It is a prime mover, which means it'll run, it'll go back and hit the cap bank, okay, and it'll keep running. You do not pull your over unity out of that. You go to your coil, take a ferrite core, run wire around it, okay? That's where you pull your energy out. That's where all your levels of saturation are. Pull your energy right out of there. As simple as that. Put as many cores as you can fit in there, man. Pull it out. You're good to go. That's how you do it. So, let me see if I have it here. I'll pull this up for you. Oh, if I could find it real quick. I built one of these machines a while back, years ago. And let me see if I can't find the right page on it. Anybody heard of the OTC X1? Okay. Let me see if it'll let me share it. And of course it won't. Hold on. Take just a second. Not what I want. Oh, why is this thing arguing with me? Okay, here we go. OTCX1. This right here, guys, it's just going to do the same thing as the gravity flyer. It's going to trip you out, okay? It's a cross between a gravity flyer and a coil. So, what do we got going on? The center part is a Tesla coil. If you've watched Sean's experiments on Wednesdays, you see his Tesla coils that are actually cone-shaped. They direct the energy. Tesla looked at it, and he says it creates more energy. Why? Because it's focusing it. You have two separate ones, a north and a south. It basically creates the one side of the null zone in the vortexes is what it actually looks like. You have that energy that goes out, okay? For each one of the outside coils that are attached to the C-shaped capacitor right there, right? That's how you get direction in a coil or a, basically your bifield Brown effect. It'll make the direction. When one's turned on, it goes that direction. It goes towards the energy. Because it's colder energy, it goes towards the heat. That's what it's doing. The plate you see in the center of the rotating disc is your capacitor plate. You can see it clearly marked on there that they're capacitors. The Utron itself is a frequency device. It creates frequency and rotation based on the magnetic field that's around it, just like the plates on the gravity flyer. It will create a low frequency in hertz. That's exactly what it's doing. Goes in, fills up the capacitor, it goes in, rotates, goes back, feeds the Tesla coil, goes back out to the C-shaped capacitors. It's a loop system, has an outside, okay, that fills up with energy because it's all aluminum. So when you get up in the air, it's going to pull it in, just like Tesla told you in the radiant energy. It will pull in the energy through that in the atmosphere itself, so it'll act like a corona motor and pull in the energy. So it will create over unity when it's in the air. Interesting concept, isn't it? Everything that we talk about every day on this channel, every kind of UFO that you're going to look at has the same thing going on. Stealth craft, UFO, UAP, same descriptions. Okay? Every time we get down to it, does the same thing. What happens when you put a radiant field over to your computer? It saturates every single MOSFET in your computer and it starts turning things on and off. That's pretty easy to understand. Static electricity does the same thing. If I go hover over your car, I'm going to shut your whole electronic system off. Was it going to recover? Yes, because I'm saturating, I'm not exploding it. Okay? Every possibility turned back on once I remove the radiant energy. They have marked UFOs that say they have radiation in the ground once they remove the UFO from the air, or it's disappeared, or whatever happened to it, right? Why? Because the radiant field is a radiation field. It literally creates it. It forces it into the ground. That's why it's always there. You start to put the stories together and what's going on. You have microwave energy because the frequency gets so high when you get so much static electricity. Your frequency goes through the roof. That's not by coincidence. That is because, very simply, the way voltage works, the higher the frequency, the higher the voltage. For every time you have higher frequency, the voltage is higher. The amperage is lower. If you have a lower frequency, it means that your amperage is higher. Voltage works that way. It's real simple. Okay? So that works out when it comes to frequency in any kind of system. Get your frequency to increase. It will increase the voltage in parallel every time. Every time. Doesn't matter. That's how you get to static electricity out of a flyback. Put two of them together, you're going to get a high amount of static electricity. Take your Tesla coil. Not joking, guys. Fill it. I don't care if you fill it with mud, sand, whatever. Let it harden. That radiant field is going to be so much higher. Why? Why would that work? Because you took out a air core and you filled it with a solid core. Now it's pushing out the energy further because you're creating heat in the system. Anytime you put anything down a Tesla coil, your frequency changes and lowers. Why? Because you're putting heat in it. Tesla himself used a wooden dowel in order to do this process. He put the wooden dowel inside the Tesla coil. It created more heat. It lowered the field. When you pull the wooden dowel out rapidly, the thing goes through the roof in the frequency department and runs out of it super fast. You have created a point of impingement. You've created a point of heat. It gives you more amperage. The more amperage you're able to pull in a coil, the further the distance in a Tesla coil. In order to get that further distance, you have to force something down the center of the coil in order for it to radiate further. It will get you a suntan. Why? Because it's radiant energy. Flat out. That's what it is. You have a radiant energy field on the inside of the Tesla coil that's negative, which means it's cold, and on the outside you have it positive. That is a Tesla coil. That's the way it works. Okay? Those are the two sides of that field. I don't care how you turn the thing on. Look, I can take radiant energy, turn on Tesla coils all day. I show my stupid experiment with my burritos. Why? Because I'm literally holding in the radiant field in order to create heat. Once I create heat, I can turn on any Tesla coil I want. I'm literally creating a gray tube in a burrito. Why? Because I know that radiant energy can be held in, and I know it creates heat. Since I have heat and it's pulsed, I can run anything I want. I can start up any Tesla coil I want. It's as simple as that. Okay? I can continue to turn them on all day long. Line as much of them as I want. As long as I do that. Then I can convert just like Edwin Gray did in his, or, you know what I mean? I can create a gray tube really easy. And then you can use high voltage DC to turn it on every once in a while and turn the whole thing hot and turn it into one massive amperage field. It's over unity in the system, guys. It's always been created that way. Those are the fields that are doing it. We've identified all of them. We know exactly how they work. It's really not that hard once you get into it. Radiant energy, by the way, beats Lenz's law. You say, well, that's strange. Isn't it when you go outside the Earth that they can't pick up a magnetic field, but they know magnetism is there? Sounds an awful lot like radiant energy, doesn't it? The same type that's coming out of your Tesla coil. It beats Lenz's law. There's no magnetism, but there is a magnetic field component to it, isn't there? That's what gets you. Because you know you found it when everything lines up the same way. You have to look at things in comparison to other things in order to figure these things out. We have all the fields. We have the understanding of it. We have the confinement, the rotation, all of it to figure it out. It's all right in front of us. I mean, that Tesla coil is the key to everything. Tesla knew that. It creates a longitudinal wave out of the center. There you go. Scalar field is a longitudinal wave. Okay? The magnetic field that you put into it is transverse. That's the way it works. You want a longitudinal wave, you have to have Tesla coil. Or create your coil in a way that it creates an oscillating field, but the inside of it turns into the scalar field. That's a geometry coil. That's a different understanding, isn't it? And you're going to create your geometry and rotation as you build it. Therefore, that field itself will have different frequencies to it. Remember, scalar builds out in layers, in height, as in temperature. As you have different temperature, you have different frequency. Understand this. When I tell you about voltage and amperage in a system, I'm literally describing how scalar works. Okay, just understand that. We all can stand on the earth and it'd be hot. We go climb a mountain, it's cold. The frequency works in the same direction. The higher we get on that mountain, higher the frequency. The lower we are under the ground, the lower the frequency. As we go under the ground, the frequency gets even less. Literally how scalar is built. It's literally how you're building it in all the energy systems you use. You just probably didn't realize it, but it's exactly what's going on. Those are the processes, guys. Hopefully you guys understand them. Yeah, Tesla coil is a step-up transformer, but it's an open core transformer. It's, create the heat in the core, which should make you think of flybacks in a different way. Where do you need the pulse? What does the core need to be? What do the outside layers need to be? That's why they can literally take clear film and put it around a coil of wire and just simply take mylar and put it in the center. And they can create a one-way direction for a high voltage. That's how they came up with the DC flyback, because they understood the simple process of how it works. It's a one-way diode. Cannot go back the other way because it cannot create a high enough magnetic field on the strip of mylar. It can't. So it can't go back the other way. It has to stay on the outside. That's as simple as it gets. I tore them down. I've showed them in my shorts on my channel. It's created the exact same way. It's just an understanding. How would you hold in a static field if you wanted to build it in a room? Well, you have to build out a second radiant field, don't you? You have to have some kind of motor that went bad in order to create that. You have to have a temperature differential in the room. The room cannot be hot. Hot creates a lot of static electricity. I understand that. But it's like a hot house on a cold day. Snowing outside, hot house, right? That cold field is all around that hot house. That's the way it works. It's holding it in. Temperature differential. You're going to have to learn it. Okay, what do we got going on in here, man? We got a bunch of stuff going on. There's some poo in the chat. Bunch of stuff, huh? Yes, it is. That is absolutely true. Now take the spacing of it and put in 2 magnets and see what the difference is. Put a little space in it, see what the difference is. You want a bit. That's what you want to create out of it. So what do I mean by that? So anytime you run a joule thief circuit and you want over unity, you wrap the core. That's 1 winding. Take that same amount of windings, but now cut it in half, wrap 1, then take the other one, wrap the other. That is a conventional joule thief circuit. You're mirroring the amount of frequency in the first coil, which is the full wrap, with both of them combined to make the other wrap. It thinks that you're putting it in resonance so it creates the same energy, but you can take 1/2 of that and put it off to the rest of your circuit, take the other half of that, put it into a cap bank. That's your free energy right there. That is how you create over unity. You have to be able to understand that to pull it. Frequency creates energy, or it draws it in, I should say. Sorry, it draws it in. Frequency is the culprit. Everything that has energy has a frequency. You just got to be able to find it. Everything will go into over unity once you put it in resonance. Why do you think we do it on the gravity flyer? Why do you think I just want aluminum? I want 1 frequency, 1 resonance point, 1 thing that resonates the whole craft. Showing the fact that aluminum resonates at that frequency is a mind-blowing idea. It means like everything in there, if you take all the plates, they're all Tesla coils to me now. All I have to do is resonate them at the same frequency that I'm resonating my Tesla coil at, and I resonate my high voltage at. Now we're getting somewhere. Now we've created more energy. Why? Because as soon as you create a resonance frequency in another object, it puts the energy in it. Why do you think crystals light up? Resonance, frequency, and compression. Simple as that. That's a geometry coil in a nutshell. Geometry coil is a mandala. It's broken down. A mandala shows you more things than one. It's showing you the vortex in a mandala. It's showing you the frequency pattern in there. It's showing you where the octaves are. It's showing you the vortex. But it also gives you a pattern to wind a coil. Simple as it gets. They gave it all to us. They were way ahead of us. Way, way ahead of us. That's why everybody looks at all these hieroglyphs. They're way ahead of us. Way ahead of us. They used frequency, vibration, and energy, like Tesla told you, comes into resonance, and it literally controls our world. As soon as you can understand that, you can start to master it. I can take frequency from a Tesla coil and turn another one on and no problem. As soon as I know what I'm dealing with in the first coil, it's over. I just create another coil to match it and I'm good to go. So, yeah, hopefully you guys understand that. Hopefully, we're doing pretty good. I'm so sorry we got off the topic, guys. I really did want to talk about the other stuff, but hopefully it was okay for you guys. And we talked about everything else. That's why I'm back on my Gravity Flyer project, guys, because I had to. Because I got information that's kind of groundbreaking for what I needed to do. And now it's a very clear direction. I've already proven that it picks up energy with the frequency. So, man, all that work I did with the Tesla coil really paid off, and learning why it's happening, how things are happening, how to build it. Telling you right now, there's a lot of people would love to have that information on how all that stuff works. So, anyway, guys, You got any questions out there? Answer them real quick, and then I'm gonna call it a good day. Right on, man. I hope it helped you out in your project, man. I really do. Whatever one you worked on. Sorry you missed half of it. Yeah. One day, man, we're gonna talk about your UFO story because I think that's amazing, and I love to talk about them. Yeah, life is music. If they only used the right frequency and went back to the old scale and the music scale, we'd have a whole different world, wouldn't we? Oh, people don't realize the amount of variables. Yeah. Dude, when I write them down, it's a huge list. You're watching it again. Thank you for that. I do appreciate it. Look, guys, if you want to become a member of the channel, you guys can. It'd be awesome. Guys, I'd love to have you. I dropped a video yesterday on the frequency and stuff like that. On how the capacitor works and tell you exactly how I'm going to build something. There's going to be a lot more on there, guys, because we really need to push this further. So everybody who's on the channel there, you guys get some extra stuff on there, and you guys get to hang out with me. And then, dude, emojis in the chat, dude. If you got them, drop them, man. Love emojis, man. Throw them up if you got them all the time. You know what I mean? Like that joke and have a good time. So, yeah, anytime during the thing. And then when other people are presenting, man, I'd be able to read the chat a lot more. So, anyway, appreciated that. Everyone have a great day. Yeah. So, yeah, I'm poor as well, man. That's the way it works. We're all poor. We're all inventors. We all build stuff. Look, I put all my money for my channel into everything I build. So, yeah, it's just the way it works. Yeah. All right, guys. Let's go to the woo one more time, and I'm taking off. Dude, I love that graphic. That's so cool. I'm going to have to do that more often. Right on, guys. Have yourself a great day.
The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality been stricken from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds. The old man builds. The old man builds. The old man builds. Fears of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to extend. The old man builds.